Your Tennessee State Standard for today's lesson to use rational approximations of irrational numbers to compare the size of irrational numbers, to locate them approximately on the number line diagram, and to estimate the value of expressions, that is pi squared. For example, by truncating the decimal expansion of square root of 2, show that square root of 2 is between 1 and 2, then between 1.4 and 1.5, and explain how to continue on to get better approximations. Your lesson objectives today: I can, or I am learning to, estimate the value of irrational numbers using a number line and long division. So you'll need to stop the video and write that at the top of your notes. Let's see if we can get that out of the way. All right, irrational numbers are numbers that cannot be written as fractions. And remember, we just got through talking about rational numbers, the different types, and how they could all be written or transformed into fractions. Irrational numbers cannot. All right, so yesterday we used the centimeter tiles to form a square with sides of 1 tile. Could you have formed a square with only 2 tiles? I want you to think about that. Be prepared to discuss it tomorrow in class. And then I want you to think about how many tiles did it take to form the next largest square. And then we're going to look at what is the square root of 1 and what's the square root of 4. And I think yesterday you said that the square root of 1 was 1 and the square root of 4 is 2. Which of those numbers do you think square root of 2 would be closer to, and why? And I want you to think about that, and we'll talk about it tomorrow. So square root of 2 is between 1 and 2. So we're going to estimate that the square root of 2 is approximately 1.5. Approximately 1.5. To find a better estimate, first we're going to choose some numbers between 1 and 2 and square them. For example, we're going to do 1.3, 1.4, and 1.5. And we talked about the square of 13 is 169. We talked about that yesterday. And since it would be 1.3 times 1.3, you have 2 decimal spaces. Therefore, you have 2 decimal spaces in your answer. And we talked yesterday that 1.4 squared is 196. Well, let me make sure that's right. Times 1.4. Times 4 is 16. 4 ones 4, 5. Just checking to make sure. And it would also have 2 decimal places. And then 1.5 squared, well, 15 squared is 225. And if we did 1.5 times 1.5, we would have 2 decimal places, so 2 decimal places here. So is the square root of 2 between 1.3 and 1.4? Or is it between 1.4 and 1.5? Now I want you to talk about that and just think about that for a minute and see how you know. And we'll talk about that tomorrow. We're going to move on with the lesson, but we'll talk about which one that falls between and how you know. All right, so the square root of 2 is actually between 1.4 and 1.5. So we can say that the square root of 2 is approximately 1.45 because that's halfway between 1.4 and 1.5. So if we were to locate and label this value on the number line, it would be right in between 1.4 and 1.5. So we could put the square root of 2 there. How could you find an even better estimate of square root of 2? Well, you know the square root of 2 is between the square root of 1.96 and the square root of 2.25. Which one would that be closer to? I want you to think about that, and we'll look at that tomorrow a little bit more closely. All right, now we're going to use the long division approach to approximate the square root of 2. First of all, step 1, we're going to write the square root problem between the square root of the perfect square before it and the square root of the perfect square after it. So we know that the square root of 2 falls on the number line between the square root of 1 and the square root of 4. And we know that the square root of 1 is 1. So we know the square root of 2 is going to be somewhere between 1 and 2. So we're going to use 1 as our whole number. Now, to get our fraction, we're going to use the difference between square root of 1 and square root of 2, or the difference between 1 and 2. So 2 minus 1 equals 1. That becomes our numerator. And then we use the difference between 1 and 4. So 4 minus 1 equals 3. That becomes our denominator. And you can subtract the first number from the second number and use that as the numerator. Subtract the first number from the third number and use that as the denominator. Once we have our fraction, we can use division to change 1/3 to a decimal. And we know that 1/3 is 0.3 repeating. Let's move this out of the way so you can see this. 1/3 is equal to 0.3 repeating. So if we use the long division approach, this would be equal to 1.3 repeating. Now, the smaller your numbers get, the further apart the answers will be from approximating it without long division and approximating it with long division. Since we know that 1.3 squared is 1.69, because we know 13 squared is 169, we know we have to increase our approximation. So that's when we would move up to 1.4 and then keep moving. So let's do the square root of 7. Let's estimate the value of 7, square root of 7, to 2 decimal places. Well, we know the square root of 7 is between the square root of 4, which is 2, and the square root of 9, which is 3. So it's approximately 2.5. And we're going to say 2.5 squared. And we're going to have to do this because we don't know 25 times 25. So 5 times 5 is 25. Carry your 2. 5 times 2 is 10 plus 2 is 12. We bring down a 0. 2 times 5 is 10. Carry your 1. 2 times 2 is 4 plus 1 is 5. So 2.5 squared is equal to 6.25. So we know that has to be just a little bit more. So let's do 2.6 times 2.6. 6 times 6 is 36. Carry your 3. 6 times 2 is 12 plus 3 is 15. Bring down a 0. 2 times 6 is 12. Carry your 1. 2 times 2 is 4 plus 1 is 5. Oh, so we know it has to be at least 2.6. Because that would give us 6.76. Well, let's do 2.7. Seven times 7 is 49. 7 times 2 is 14 plus 4 is 18. Carry down a 0. 2 times 7 is 14. Carry your 1. 2 times 2 is 4 plus 1 is 5. 8 plus 4 is 12. 5 plus 1 plus 1 is 7. So we know that the square root of 7 is somewhere between 2.6 and 2.7. So we're going to say to two places that the square root of 7 is approximately equal to 2.65 because that's halfway between 2.6 and 2.7. And that's the end of the lesson, and we will work more on these. Well, actually, let's do square root of 7 with the long division approach. I'm going to do it right here, and we'll do it in a different color. So we know it's between 4, square root of 4, and the square root of 9. Somewhere between 2 and 3. 7 minus 4 is 3. So that becomes our numerator. And 9 minus 4 is 5. That becomes our denominator. And if we change that to decimal form, that would be 2.6. So you can see this is closer. The larger the number under the radical sign, the closer our estimate with long division will be to approximating with a number line. And that's the end of the lesson, and we will work on these tomorrow.